now we want to talk about where do galaxies come from in the first place. So the initial formation of galaxies we think happens because of the collision of globular clusters. So after the Big Bang, there were huge gas clouds. And then those gas clouds, as they fragmented, turned into globular clusters of stars. So millions of stars being born at the same time. So let's represent that by, here is a globular cluster, and then over here is another globular cluster, and then over here is another globular cluster. And then these globular clusters began to interact with each other because of gravity, and they began to collide, and then that, in turn, formed the first galaxies. So notice that this is very similar to the formation of a solar system, in which you've got this debris, dust and materials, and then it began to collide, and then that turned into a solar system. So very similarly, these globular clusters turned into a galaxy. Now, there are different shapes of galaxies. So you can have spiral galaxies, such as the Milky Way galaxy, which about 47% of all galaxies are spiral galaxies. And then about 50% of all galaxies are elliptical, and then only about 3% of galaxies, they really don't have any kind of structure. And notice also that the irregular galaxies are very, very small, whereas the spiral and the elliptical galaxies are very, very large. And then you've got your peculiar kind of galaxy. And at first, they did not know what these things were, and so that's why they called them peculiar. And I like to think that who actually figured out what a peculiar galaxy was a graduate student. And so he said to his professor, hey, do you know that that peculiar galaxy is just two galaxies that are colliding? So can you see that you've got one galaxy that's rotating like this, and then it's in the process of colliding with another galaxy that's flat like that? And then I like to think that the professor said, you're fired. Okay, and then he went on to write the paper taking credit for the peculiar galaxy and what it was. So a peculiar galaxy, it's not really a new type of galaxy. It's just a collision between two regular looking galaxies. And so you can have the spiral galaxy, you can have the elliptical galaxy. Now, just as though you can have an ellipse that's shaped like this, or an ellipse can be shaped like a circle. So this is a degenerate case of a regular ellipse. So similarly, you can have elliptical galaxies that look like a football, but you can have other elliptical galaxies that are perfectly spherical. So that's another class of galaxies. Okay, now the question is, how then do galaxies achieve their particular shape? So we said that they result from the collision of these globular clusters. Okay, so what could modify this idea in order to give you these different kinds of shapes for galaxies? Well, we already mentioned the peculiar is just a collision of two galaxies, but what are some other possibilities? So the first one has to do with how fast was the original material that formed the galaxy, how fast was it spinning? So that if you have something that is not spinning very quickly to begin with, then when it collapses, it's going to end up just being spherical in shape. So that's going to be your elliptical galaxy. On the other hand, if this material is rotating rapidly, as it gets smaller, it starts to rotate faster, because like the ice skater, when they bring in their arms, they spin faster, and so that's going to cause collisions that tend to flatten it and turn it into a disk. Does that sound familiar? Well, that was our explanation for how our solar system ended up being a disk. So they took that exact same theory and applied it to galaxies to explain why some galaxies are flatter than other galaxies. Okay, so let's take a look at another theory. Now this one is kind of complicated, and this is going to have to do with how dense was the original cloud to begin with. So some clouds are more spread out than others, so that means they have lower densities. Okay, now let's go back to when we were talking about the formation of stars, and we said that thermal gas pressure was a bad thing. So that if you have a cloud of material, and we want this cloud of material to turn into a star, the individual gas molecules inside of this cloud are moving in different directions, and they're moving at different speeds. And the speed that they're moving at, the average speed of these molecules, is going to be due to temperature. So the higher the temperature, the faster that these molecules are going to be moving around, and that's a bad thing, because the faster that they're moving, the more thermal gas pressure that they have that is keeping gravity from collapsing the cloud and turning it into a star. So thermal gas pressure is bad for star formation. Now, if you had a cloud that was more dense, then that means it's more conductive of material. Okay, so let's think about the difference between if you have air that's at 100 degrees Fahrenheit, okay, and you put your hand to it, okay, it feels warm. Okay, but if you have a piece of aluminum and it's at 100 degrees Fahrenheit and you grab a hold of that, okay, it's very, very hot. Okay, that's because aluminum is a good conductor of heat. It allows heat to escape the piece of metal easier than what air does. And aluminum is more dense than what air is. Okay, so the more dense the cloud was, the more conductive it would be. And so that would allow this heat that was building up inside of here to escape. And if that heat escapes, now the thermal gas pressure goes down, and so now the cloud can collapse due to gravity. Okay, so now what has that got to do with galaxies? Okay, so that means that stars are going to form before they can settle onto the disk, and so this is the reason why you would end up with a spherical gas cloud. The stars would form because the higher density means less gas pressure, means the stars can form faster. They're going to form before they can settle into a disk, and so that's the reason why you have a spherical gas cloud. On the other hand, over here, let's say that you've got a gas cloud that is low density. That means the heat can't escape the gas cloud very easily. So that means that the stars are going to form slower, and then those stars have enough time to settle onto the disk, and then you end up with the spiral galaxy. So this is kind of complicated, but see if you can remember all of that for the exam. Okay, then another reason why galaxies might look different is because of their mass. And so if your original cloud doesn't have very much mass, it's not going to have very much gravity. If it doesn't have much gravity, there's nothing to pull it in and turn it into a structure. So that means that your gas cloud is just going to stay amorphous. And so that would be your irregular galaxy. So notice that irregular galaxies were very small, and that the ones that had a structure, like the elliptical galaxies and the spiral galaxies, were very big. Okay, then another possible mechanism for changing the shape of a galaxy is collisions. Now, collisions between stars are very, very rare. Okay, think about the size of a typical star so if this table right here, so let's say this table is 2 meters in length, okay, and let's say that that represents a galaxy. So that represents 100,000 light years across. How big would a star be in comparison to this 2-meter table? Smaller than the head of a pin. Okay, so that if you had a head of a pin and you take it back here somewhere, and then you take another head of a pin and you put it over there somewhere, and then you just randomly allow them to move around, chances of those two pins colliding is very, very small because they're very small objects. Now, on the other hand, let's say that in this room, which is about 10 feet by 10 feet, I've got 2 tables that are 2 meters long, and I start to randomly roll them around in this room. What's going to happen? They're going to collide. Okay, so galaxies do tend to collide, but the individual stars do not. Now, what's interesting, though, is that when the collision occurs, it's going to compress the gas. And so when that gas gets compressed, that's going to trigger star formation. I forgot to mention that with the arms of a galaxy, those density waves, as they're rotating around, are pushing gas in front of them. So they're acting like miniature bulldozers. That's why the arms of a galaxy are visible, is because they're triggering new star formation, and you can see the light given off by those new stars. Similarly, when 2 galaxies collide, they're going to compress the gas in between them, and that compression of that gas can trigger new star formation. So I got this little video here that I want you to watch on YouTube, Spiral Galaxy Collision in 360 degrees. Now, what's amazing about this video is that it's only maybe 30 seconds long, but it probably took a supercomputer a year to make the video. Okay, why? Because what they did was they took like 10,000 particles and they computed their speeds and their distances away from each other. And so they made a galaxy out of 10,000 particles. Then they made another galaxy over here out of 10,000 particles. Then with the supercomputer, they calculated the gravitational forces of this 1 out of 10,000 particles being caused by the gravity of every other particle. And then this one over here, they did the same thing. So they calculated the interactions of 10,000 particles with 10,000 particles, and then they set them colliding to see what kinds of structures would form. So I want you to watch that video. Okay, do it. Did you do it? Okay, was that cool or what? Okay, and then did you notice that when the 2 galaxies collided with each other, did you notice that when you had this one over here and then this one over here, and after they collided, they were kind of connected by this object that kind of looked like a bar. Okay, and so this is one possible explanation as to where bars come from. Also, did you notice that the arms got really distorted? So that you could start with a elliptical galaxy and an elliptical galaxy, and then after they have collided, you could end up with a spiral galaxy, depending on how they were spinning. initially. So these collisions occur quite often in the universe, and they can change the shape of a galaxy. Okay, let's take a break. And when we come back, we're going to talk about the energy output of galaxies.